Hi everyone, I'll be showing you how to build and analyze a structural beam in RISA 2D. You can easily obtain the demo version for free by Googling RISA 2D, following the links to the RISA website, and downloading the trial version. Once you have an idea of the dimensions of your beam and the loadings that will be placed on your beam, you will need to start building your beam in RISA. First, you'll need to identify where the joint coordinates need to be. In order to do that, you have to hit the Joints Coordinates tab in the Data Entry toolbar, which is right here. Come over to the new window that appeared, click in the box, and the first joint will automatically appear. In order to add more joints, hit Enter. In order to delete a joint, right-click the joint that you want to delete, come down here to Delete Current Line, and the joint will be deleted. For the purpose of this demonstration, we'll use a beam with two joints. I'll put the first joint at the origin, which would be 0, 0, and the second joint I'm going to put 50 feet away from the initial joint. Once you're done placing your joint coordinates, you can go ahead and close the joint coordinates window. Next, we're going to have to place boundary conditions on our joint coordinates. So click the boundary conditions button in the data entry toolbar, and a boundary conditions window will appear. Click within the boundary conditions window, and your first joint will appear automatically. For this demonstration, we're going to need both of our joints in the boundary conditions window. So hit Enter, and the next joint will appear automatically. In order to apply a reaction in a specific direction, you're going to need to click inside the box and hit R. And once you click away from the box, a reaction will appear within that direction. In order to get rid of that direction, just click within the box and hit the delete button, and the reaction will go away. For this beam, we're going to have joint N1 have a reaction in the X and in the Y, and N2 have a reaction in the Y. Once this is done, you can go ahead and close the window. Now we're going to have a member connect our two joints together and act as our beam. In order to do that, we're going to have to come over here to the Data Entry tab and click Member. A member window will appear. Just click within the window and a generic member will appear. In order to make the member appear on the screen, you have to connect the member from one joint to the next. It doesn't matter which joint it connects to, but it has to be to two joints. So we'll just switch this joint to N2 and click, and our member appears. Once our member appears, you can go ahead and close the window. Now that we have created a member, we can now start applying loads to the beam. There are three different basic types of loads that you can apply: joint loads, point loads, and distributed loads. Joint loads can only be applied to the joints. Point loads can be applied anywhere to the beam, and distributed loads can be also applied anywhere to the beam. First, we'll go through joint loads. Click on the Joint Loads tab in the Data Entry toolbar. The Joint Loads window will appear. Click within the window, and your very first joint will appear in the joint label. You can switch this label to any label you want as long as it matches a joint that you have used. This tab here will show what the joint load will do, whether to act as a load, a displacement, or a mass. Since we're applying a load, we're going to keep it as load. This tab shows what direction the load will act on, whether it act in the horizontal direction, the vertical direction, or it'll act as a moment on the beam. We're going to have it act in the vertical direction, so we're going to choose Y. The positive vertical direction is up, and the positive horizontal direction is to the left. So since we want a load on the beam to point downward, we have to apply a negative sign to whatever magnitude our load is. So we'll put -50, and we can exit out the window. The next type of loading is called a point load. You can apply a point load by hitting the point loads button in the data entry tab. Point loads window appears. Click in the window to start plotting a point load on the member. Just like in joint load, they have the direction of the magnitude and the magnitude. But in point load, since you can put it on any part of the member, it has the member label instead of a joint label. This member label corresponds to this member, since this is the only member in our system. The location corresponds to either a percentage or an actual distance in feet along this member. Just like in joint loads, in order to get a loading that is pointed downward, we would have to put a negative sign in front of the number. So for this, we'll put -20. And for location, if left untouched, this location of 0 feet would be directly above this joint. But we can go ahead and put in 20, and that would indicate 20 feet from the beginning of the member. So from this joint out 20 feet, this point load would be placed. Once your characteristics for your point load are correct, you can go ahead and exit the window. Okay, now for the last loading case I'll show you. It's called distributed loads. You can go over to the data entry toolbar and click distributed loads. The distributed load window will show up. Click in the window. Now this is just like a point load, except for it has a starting magnitude, an end magnitude, a start location, and an end location. Now for a distributed load, it applies a loading all the way across a certain location. So what we're going to do is we're going to apply a starting magnitude of -10 and an end magnitude of -15. And we're going to have a starting location of 25 feet, which would be the middle of the beam, and an end location of 50 feet, which is the far end of the beam. Now our distributed load is done. We can exit it out. Now that we have all these different loadings, we're going to make sure they're in the right direction and the right magnitude. So what we're going to do is we're going to press this button up at the top next to BLC1. You can toggle on and off the loads so that way everything doesn't get crowded. So once you hit it, all your loadings will show up. This is the joint load that we applied. This is the point load, and this is the distributed load. See how the distributed load starts at this magnitude and ends at this magnitude. Now that we can see that all of our loads are in the correct direction and have the correct magnitude, we can go ahead and either keep the loads visible or we can hide them. It's your personal preference, but for now we're just going to keep them on. So the next step is we'll go to loading combinations. So you click the load combinations button in the data entry section. Now the load combinations window appears. Click in it, and all these different load combinations and factors show up. Now what this is for is to give certain loads certain degrees of importance. So if you're doing a load combination between dead load and live load would get more importance than dead load. So the live load will have a higher multiplication factor than the dead load. But for now, since we are just applying loads and it doesn't matter, we can just choose our BLC, which is the basic load case, and then put a factor of 1, which will multiply all of our loads by 1 and they won't change. Now to make sure that all these loads are in our basic load case of 1, you can come back here, click joint loads, and you'll see that up here this is in the BLC of 1. If you switch it, you'll have to put another BLC in here, and it would be a different basic load case. But since that's a BLC of 1, that will be affected in here. And then same thing with point loads. Same, it has a BLC of 1. And the distributed load also has a BLC of 1. So all these loads will be accounted for in this loaded combination. I can go ahead and exit this window. The final step to analyzing this beam is to click the analysis button. It performs the analysis based upon our dimensions and our loadings that we applied to the beam. Now all I gotta do is hit this button, and this asks for what load combination you want to do. Since our BLC is 1, this is the only load combination in there. So we can go and hit solve, and it automatically solves everything we need for the beam. And over here we have our results tab. It has our joint reactions, it has our joint deflections, and everything else you'll need to help analyze this beam. As you get more experience with RISA, you can further indulge in the other functions that the results tab shows. But as of right now, this is just a beginner tutorial for how to analyze a simple beam.